people? I'm Ivan Topolnjak. I'm not Croatian. Don't speak to me in Croatian because I barely understand it. I'm from Venezuela, but I do live here. My grandfather was Croatian. That's why I have this weird name. Um, I work in Camon and Camino. Camon is a monitoring tool for the JVM. And today we're going to talk about a few things that I think they're general advice in monitoring in general. But we learn these things by trying to monitor applications running on the JVM. So I guess a lot of you are actually running something on production right now. Some code you wrote is there running. And do you even monitor? Do you know if that thing is alive? Do you know if it's processing things the right way? Is it failing? Is it fast enough? Is it as it's supposed to be? Or do you even have an idea of how it is supposed to be? Usually, the answer to this is, I don't know. People don't do any sort of monitoring. They just push this thing to prod. And when something breaks, when something is so horribly wrong that you just cannot figure out with the logs, then you start thinking, oh, maybe we need some metric solution. Maybe we need to measure latency for this thing, or measure how our connection pool with the database is behaving, and so on. So this talk is like give you a few ideas of how you can get there, what you should need, and what things you should be aware of so that you don't make the mistakes that a lot of people are doing right now. So first thing is, there are three pillars of observability: logs, metrics, and tracing. I think everybody knows about logs. I'm not going to say anything about logs. This is just a little piece of advice related to logs. We're going to be mostly focused on metrics today, what to do related to metrics. And tracing and distributed tracing in general is a whole different topic. It deserves its own space. So we're not going to cover it today, but we're going to do a meetup in the Scala user group in Croatia. So if you want to go there at some point in late March, we're going to schedule it and do it. So if you're interested in distributed tracing, go there. So what you should be doing, first you need to create a plan. And that's like the simplest thing you can do. Like, don't try to get, oh, I want to get metrics about everything. I want to measure every single method invocation, blah, blah. That doesn't work. What you should be doing is start simple. There are three main signals that tells you whether your application is good or not: uptime, latency, and error rates. You can start just by that. Is my application up or not? Some people only care about that. Is it up? If it's slow, it doesn't matter as long as it's up. If it's doing some batch processing, it takes 1 hour, 5 hours, it's the same for you. Now, latency becomes important when you start having users interacting with your application. So there's an A user, there's someone in a browser who click save and is waiting for 10 seconds for this thing to say saved. So you don't want that kind of things to happen. So you start caring about latency, and of course, error rates, is this thing finishing properly or not? Start with basic objectives. I want application to be up most of the time, to be relatively fast, and not to have errors. Then you close this loop. How do you close it? Well, you take this matrix, you put it somewhere, you look at this data, you refine, because obviously what you do first is not going to be enough, but at least gets you a starting point. Then you go through this process again and again and again until you have the exact things that you need to monitor your applications. Usually, this is an ever-going process. When you start putting some metrics, it works. Then when you have your first production incident and these metrics didn't help you, then you will realize, oh, it would have been so nice if I could have the size of this cache, or if I had a metric with the cache miss count for this particular cache, because that is what was causing my application to be slow. So this is a process that you don't do once. You do it several times. So the sooner you get into it, the sooner you can iterate to get the right information where you need to troubleshoot your applications. Now, if you're talking about these objectives that you have in terms of errors, latency, and uptime, you have to have a right way of expressing it. Just saying, I want my application to be fast is not enough. Because what does it mean to be fast for you? Like, if you are in the JVM, there are a lot of things that can affect latency. So if you're talking about Availability, for example, you will usually define your service level objectives in terms of 9. How many 9s of availability you want to have. If you want latency, then thinking about averages is not the right way to do it. You should think in terms of percentiles. And we will see an example of how to do that. And error rates, well, that's pretty simple. I don't want more than 1% of operations to end up in errors. For uptime, these are numbers that maybe some people don't know. They think that they are like really, really highly available, but having 3 9s means that you can be 1 minute and 26 seconds down a day. Some people take that time just to redeploy the application. You make a config change, you redeploy, and it takes you that time. So are you achieving 3 9s right now? Maybe not. Maybe a simple mistake in the configuration can bring your availability to 98% or something like that. So beware of measuring and what are your actual limits. What does your business allow you to have? If you talk about latency, then fast, as I said, is not enough. But then how do you present this? Usually what you will have is a number that is the maximum latency you can have. So you cannot allow yourself to have any request over 1 second, 5 seconds. It depends on your business. And there's also the other side of the spectrum, which is the typical case. The typical case is never the average. The typical case could be the 50th or the 80th or the 90th percentile. So once you have these two boundaries, like what is the typical case and what's the worst case you can have, then you can have a couple more percentiles in between. And your request latency should always be within these latency brackets. If you just talk about averages, can be so misleading. We're going to see some examples of how that can go wrong. These that I just said about how to express the service levels objectives is something we have been saying for years. I've been working on monitoring for at least 5 years now. And people sometimes think like, oh, what the fuck are you saying about percentiles? Like we do averages because that's what we get from our monitoring tool. Well, now Google is saying this as well. This is a site reliability engineering book by Google. You can read it online for free. Read chapters 4 and 6. They are self-contained. You don't need to be reading from the start to understand these chapters. And you will understand why I'm saying this, why this is important, or you can find me after the talk and we can just talk about it. I get freaky when talking about percentiles and metrics and stuff, so that's a good thing. So when talking about latency, never do averages. Why? Horribly misleading. How can I prove that to you? You see these 3 things, so a bunch of values equally distributed across 1 and 100. Some other thing where some values are more here, more there, some values at the beginning. Like, it doesn't make any sense at all, but all of these 3 distributions there have the same average of 50 milliseconds. So how is your application behaving if you're looking at averages? Is it like fully distributed? Is like this? Is like that? You have no idea if you're just looking at averages. Now, how does latency look in real life? This is how it looks like. You usually have a region towards the left of your histogram chart where most of the measurements are there, and then there's a long tail that is usually governed by GC pauses, external resources, or CPU-intensive tasks. So this is how things usually look, and if you try to look at the average of this, then you will get a misleading idea of what is really happening with your application. So never use averages. Not good at all. Then, of course, don't average summaries. One thing that happens a lot is that, okay, we're using monitoring tool X, and then this tool gives you the average latency for 5 nodes that makes your application. And then you take these 5 nodes and you average it in several ways. One is, well, to get the application latency, you take 5 averages, you sum them, and you have the application average. That's a lie. You have percentiles that get calculated on each of these nodes. Is there a mathematical operation that can aggregate 5 percentiles and give you a right value? No. Whatever you get is bullshit. You're lying to yourself. So don't lie to yourself. make sure that when data gets aggregated, you know how it is aggregated and whether the value you're getting out of it makes sense or not. Usually it doesn't make sense. So be aware of what you're doing with your data. Also, don't get obsessed with throughput. Like usually, when people start getting to the monitoring, yeah, okay, so I'm going to do a load test, and I'm going to put all these things, and I'm going to see if I can do 30,000 requests per second. And okay, good, that is a novel cause that can be done. But that's not the only thing that affects your application. So what typical case, something that happens a lot, like we work a lot with ACA, and Common supports monitoring ACA, and blah, 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 blah. And people usually get obsessed with this part of the charts. So what is the throughput of my actors, and what is the latency of these message processing? And if you look at a chart like this, it's just like, yeah, it seems like there are 3 instances that are like, there are a couple of instances, and they're like processing at pretty much the same rate. That's good. But then you look at other charts where there's a time in mailbox, for example. Every time there is a queue, things could be piling up there, and the consumer could be consuming a steady rate, but it doesn't mean that things are not piling up in a queue. That could be an actor if you're using ACA. That could be a Kafka topic if you are using Kafka in your application. So it could be a stream where things are getting, well, hopefully back pressured, but things are waiting to be processed, and you are missing that because you are only focusing on throughput. And if throughput stays the same, then you think everything is fine. And it's not always the case. So look at other signals. Other signals that usually are important are garbage collection. This is something that really helps, really fucks up your application. It doesn't help. It does the complete opposite. And sometimes people think, oh, yeah, I just have this application, and I need to have a lot of things in my heap, so I just started running it with 10 gigabytes of heap, because that's how you solve this problem. And then suddenly you have 10 seconds GC pauses. How can you justify that? People sometimes don't even know. Like most oftentimes when people go and bump the heap configuration just because they got an out-of-memory error, they do this without knowing that this is affecting the time your application is going to spend in garbage collection. So look at other signals, because there could be easy, low-hanging fruit for you to optimize on your application. Also, hiccups. One thing that people don't seem to notice also is that your application is just one more process on the server. So one thing is you scheduling threads to do things at the right time, at the right moment. Another thing is that the operating system is scheduling your application to run. So it could be that the operating system said, okay, I want to do this other thing now. So you got pauses that are not related to garbage collection, but that are still affecting the latency of the services that you're providing. So you can broaden your view and look at a bit more than just latency and throughput in the app. Also, get to know your tools. This is something that it's so hard to put into people's minds. Sometimes people say, everybody's talking about library X, so it has to be good. So all I'm going to do is take library X, put it in my app, and boom, now I'm cool as well because I'm using the library everybody's using. And there is one particular example that I find very like alarming when it comes to metrics, because everybody knows these drop wizard metrics, right? It before was called Coda Hell metrics. Anybody who is doing something on the JVM and does something with metrics will know that this library exists, or maybe they're using it right now. Now, there is a histogram implementation there. When you start using that thing, the default configuration that nobody ever cares to read the manual for makes assumptions on the data that you're putting in the histogram. It makes the assumption that data has a normal distribution, and then based on that, it drops data. It has exponentially moving average, blah, 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 blah. The thing is, when you put data there, it is assuming it's a normal distribution, and it drops data. So I took a data set, the same data set that I used for one of these slides, I don't remember which one, and I recorded it with drop wizard metrics, and then get the values out of it. So these on the left are the values I got from drop wizard metrics, and that one over there is the actual values that you should be getting for this data set. So the max is half what it should be. So if you are just looking at the max latency you had, it's wrong. Percentiles are wrong. Everything you see here is wrong. What is more interesting is if you run the very same application again, you get different values. Same data set, same library, same everything, different values. Why? Because of the way this works by default. People don't know this. And then if you're looking at this, like this time the max latency turns out to be a third of the actual max latency. If you're looking at these kind of things, you might be thinking that your application is running fast, and it's not. But the library is cool. Everybody was using this, so this should be right, and it's not. And it's there in the documentation. You just have to read the documentation to understand what this is doing. So don't trust me, don't trust anyone, trust the code. When you get a new library in your system, take a look at it, see what it does. You don't have to become an expert on it, but you have to understand the trade-offs of each of the libraries you bring into your class path, because you are assuming a technical liability on a code that someone else wrote. So you better do it responsibly. Then sampled metrics. It's basically the same as we just saw. This library with the default reservoir is randomly dropping data. If you are using something that does sampling for metrics, you're doing exactly the same thing. You will get the same results. You're randomly saying, oh, well, this measurement here is not worth taking because I want to save on bandwidth or whatever, and then you drop data. Then whatever data you get at the end, whatever latency measurements you get are wrong, are a fake vision of what could be happening in the application. And also, of course, UDP. I'm talking most specifically about StatsD because it's something that, it's so simple to put it. It's so like, you just run this little daemon here, you throw data there, and it magically appears in some Grafana dashboard. But there are costs related to this. First of all, you are going to lose data. When you're sending data through UDP, there are several, like in the specific case of StatsD, there is the kernel buffer that could be overflown, and then the kernel will start dropping data if the application is not reading enough, which can happen while StatsD is flushing data to the backends. And also, it's not free. Like when you write something to UDP, yeah, it's fire and forget, good, but that's not a non-blocking call. Your code is blocking while this thing goes all the way down from user space to kernel space for this to be flushed, and then your application gets back to control. So if you're using an application that's a library that is not doing local batching or anything like that, it's just throwing data directly on the network, you are introducing latency by using UDP, which is free, non-blocking, and fire and forget, but it actually hurts your apps. You should measure how it hurts your apps. And usually people think, oh, no, it's UDP, so it's so nice that I will just use it. It doesn't cost anything. And the only piece of advice I have related to context is, to logging is log with context. When you start logging, you have your application running in development, and you run one request at a time because you are developing. You're doing something, testing. Oh, yeah, it went to the database. There was an error, blah, blah, blah. But when this thing is running in production, you will have, hopefully, if you have some nice environment, several requests happening at the same time. And finding 10 lines on your log saying exactly the same thing about what happened with the request, like how do you know which one is related to the specific request that you're trying to troubleshoot? So 10 requests, one of them went wrong. How do you filter out the logs? So usually you will have some sort of request ID or something that you can use to correlate logs so that everything that belongs to the same request going through your application can be found. Like then you can, if you get one of these IDs, you can just go to Kibana or any login service and just find whatever it is that is related to this request. And of course, understand your platform. Like, this is something that people usually overlook, especially when doing things like Akka, because it's like, yeah, of course, if we're doing Akka, we're going to be so fast and so reactive and so everything. But they don't take into account, like, it is no longer like this. This is the typical world where you have everything working on one thread, like servlets, super simple. You can use thread locals to keep context. You can put this request ID in a thread local and then, or put it in the MDC, and it will just work nicely because that is how simple things are when you're doing this. But if you go into a reactive application, then there is no longer a single thread related for this. So a single request could jump across all threads in your thread pool to get resolved. And then you can no longer rely on MDC unless you have specific ways of propagating MDC across these asynchronous events. And this is something that happens with Scala futures. If any of you is using Play, every time you use Play, this happens underneath. If you're using Akka, this happens underneath. And I think lately there's a trend in the Java community. By the way, I'm Scala guy, not Java. Sorry about that. There's a trend in the Java community to go into reactive things. I realized, okay, there's Spring Webflux, there's reactive extensions. Like, there are a lot of things happening related to reactive in the Java community, and it probably will soon come some more mainstream concepts. So before jumping into that, make sure that you know how it works underneath so that your observability tools will be able to work with these things. And if they don't, then you will know that they don't work, and you will have to do something about it. So what are the options if you want to get metrics and monitoring and observability? Drop wizard metrics. This is like the typical case. Everybody knows this one exists. It has a hierarchical metric model. This is a metrics-only library. So the only thing you can do with this is collect and report metrics, and it has a reporters abstraction that you can use to send data from drop wizard metrics into something else. I wouldn't recommend using this, but they're working on a new version that will have support for dimensional metric model. So instead of having this typical name like having to encode dimensions of your data and the metric name, they're going to support metric name plus tags, which is what everybody else is doing. So currently, I wouldn't recommend you to use this, but there is a new version in development which will bring dimensional models. Then there is Micrometer. Did any of you heard about Micrometer before? Well, yeah, it's brand new. It's really new, but actually it's going to be the default metrics collection library for Spring Boot 2.0, and it's about to come out. So there are really bright people working on this. It has a dimensional data model as well. I think it's a way more polished library in comparison with drop wizard metrics. Also, they have proper histogram support. They're using the same abstraction that we are using for capturing latency information, and they have several integrations available. So you have Prometheus, Atlas, blah, blah, blah. Like, this is going to be the default thing, and all you have to do to start monitoring with this is just add a jar in your Spring Boot application. So you have no excuses to say, oh, it's so much work that I cannot do it. So other option is OpenCensus, is also new. This one is developed by Google. It is a tracing and metrics library. It's not just metrics as the previous two. It has also a dimensional metrics module. Currently, it is very focused on the tracing part of this of observability, and I think the metrics part of it needs to evolve. Actually, it's not very clear how it works. The documentation is not very clear on that part, so you basically have to be reading the code and figuring out what it does. And of course, come on, this is the one I've been working on for the last 5 years. And come on is a monitoring library for the JVM, so it covers metrics, distributed tracing, and context propagation, because all of these things that I talked about end up needing some way of correlate events, especially if you're in a reactive environment where you need to, jump across threads and so on. It has built-in support for Play framework, Akka, JDBC. One important difference between Common and some other libraries is that we use agent-based instrumentation. So there are a core set of libraries that you can use with you have the APIs for recording metrics, for creating tracing, and so on. But if you don't want to do that yourself, we have instrumentation modules that can bring that for you automatically. So you just put, the Common Play module, you start your Play application with this, and then you start getting metrics without having to modify your code, which all other options require you to do. You need to somehow put your metrics instrumentation there, except with Micrometer because of Spring Boot actuator, blah, blah, blah. So what if you want to put some Common in your service? How do you do that? It's simpler than it seems. You add your libraries, whatever library it is that you need. You add configuration. In the case of using actors, you need filters if you need to report data to Datadog or to Prometheus or whatever. You need to configure certain details of where are you sending this data to or where are you exposing it. And you add your reporters. I want to add a Prometheus reporter, Zipkin reporter, and boom, that's it. You get distributed tracing, context propagation, and metrics for your application. Also, in the case of using instrumentation, you need to start your application with the aspect JWeaver, which is basically just add minus Java agent, blah, blah, for the JVM to recognize this option. And we have a SVT plugin for that in case you're lazy and you don't want to do it yourself, so you just put the SVT plugin. If you want to log a request ID, you just add this configuration, like actually this little line on the top is the important part. And Common will automatically create traces for you. It will have a trace ID for each request that goes through your app, so you can just log it, and boom, you have logging with context. Configure your Prometheus, Grafana, Zipkin, whatever it is that you have, and then just go there and look. If you are looking at Prometheus, you're going to probably link it with Grafana. You are never going to use the metric explorer in Prometheus itself because it's kind of very basic. In your logs, you will have trace IDs. If you look at Zipkin, you have this explanation of what is happening on each request. Imagine seeing one of these bars for each JDBC request, each thing that happens in your application. Jagged is another tool that gives you the same kind of functionality. And if you want to record metrics by yourself, you have APIs for doing that, APIs for tracing. And since our idea is that you instrument once and report anywhere you want, if you need to report to something that we don't support yet, you just implement one of these interfaces and you're done. You have a new reporting thing. So all these modules are available, and I'm running out of time. And of course, just in case you need, this is where I work, Camino, monitoring platform for applications running on the JVM. We made this just for Common. We have distributed tracing, opinionated dashboards. You just put Common, start reporting to Camino, and boom, you immediately get value and get easy ways to monitor your application. And that's it. Thanks a lot for coming. I think there will be no time for questions, but please reach me in the hallways. I'll be more than glad to talk and help.